Okay, so this is an inclined plane where we're going to put the ball. So what's going to happen here is the ball is full potential energy, but when it rolls down the ramp, it's going to gain kinetic energy. As it starts gaining, but as it goes up the lever, it starts losing potential energy. At this point where the lever goes like this, it's almost out of kinetic energy, but as it flips down, it gains kinetic energy again. But as you can see, this has to be a lot more inclined because the law of conservation of energy says that some of the kinetic energy is also lost in sound, as you can hear it, or in friction as it burns with, even though it's very little here, with the plastic edges. So continuing, then we'll knock down these dominoes, which fell. Then it would hit this wheel and axle here, which would then later hit something to get to that step. But we haven't figured that out yet. Okay? Then here, we have dominoes. And then these dominoes would knock down a golf ball. This golf ball would roll down here to here, go like this. But then this part, as you can see here, would then lift up the ping pong ball into here and rolling until it got to here. Then the ping pong ball will run down this, jump, well, hit the floor, jump, and go into an object, being that my final task. Okay, so our first step in the RUbe golberg machine is the inclined plane. In the inclined plane, there's a lot of velocity going on. Well, it's really high, the velocity. As it starts here, it accelerates. The acceleration rate here is 3.3 meters per second. Okay, the next step is the lever. This is we tried to find a triangle, but this is the closest we could find. In the lever, as the ball starts here, the ball is full of kinetic energy. But as it starts to rise and go up the lever, it starts to gain potential energy. So and the law of conservation of energy says that there always has to be the same amount of energy. So a lot of energy is lost in sound, as you can see here, or in friction with this, even though it's minimal compared to the sound. That's why the inclined plane has to be so inclined. Then here it's the domino effect in a circle, well, in a curved line. Then it'll hit this sort of hinge. Here are the hinges and tilting it over so that it hits this wheel and axle. The wheel will move, but the axle will stay still. Then later, hitting this ball, and then that ball topples this tower of Jenga blocks. Then the Jenga blocks have the domino effect over here. Then hitting this ball, and this ball will then supposedly fall into this cup. And this ping pong ball will be lifted by this cup into here and will finally end here. Okay, to get acceleration, you have to do velocity final minus velocity initial. We already know that velocity initial is 0, so it's technically just velocity final divided by time. So, the velocity, to get velocity, you have to do distance divided by time. The distance here to here is 30 centimeters, and it took 0.3 seconds to get from up here to down here for the golf ball. So, we do distance divided by time would equal 30 divided by 0.3 equals 100. 100 divided by 0.3 equals 33.3 centimeters per second, or acceleration equals 33.3 meters per second. Take 21.